Hey folks, welcome to my channel Number Pen. We have the problem on our screen. A function is defined as follows. Is this function continuous? So we've been given a function which is taking the value 0 for x less than 0. It's taking the value x for, I think this is 0 less than or equal to x less than 1. And it's taking the value minus x squared plus 4x minus 2 for 1 lesser than or equal to x less than 3, and it's taking the value 4 minus x for x greater than or equal to 3, right? So looks like we have a lot of work to do in this particular problem. So we have solved similar problems in the past, so let's go about solving this problem in parts, right? And what do I mean by parts? The various intervals of x where this function undergoes a transformation, right? So our first part will be x lesser than 0. And what is that? It's belonging to the interval minus infinity to 0, right? Open interval, folks, remember that. All these things are pretty important, though, which is where we tend to make mistakes while representing it, or more importantly, while understanding them, right? So I'm going to call this x belonging to minus infinity to 0. And what is my f of x? F of x is 0, right? So I call that, I know that is continuous, right? So I will not go into the detail. Let's move to part 2, right? And what is my part 2? My part 2 is again my open interval 0 to 1. And you observe that this function undergoes a transformation at x equals 0, which we will have to discuss separately, right? So what is my next interval? Open interval 0 to 1. And what is my f of x in this interval? My f of x equals x, right? Which is a simple linear function, and we do not have to worry about it. We know that it is continuous in this range, right? And then I go to my part 3, which is 1 to 3, right? And we'll have to notice and come back to examining the point x equal to 1, the continuity of the point function at x equal to 1. So our part 3 here is x belonging to 1 to 3, right? And what is that? Open interval 1 to 3. When I say open interval 1 to 3, it means it does not include the point 1 and 3, right? We have this function f of x minus x squared plus 4x minus 2, right? And this is a polynomial of degree 2. It's a quadratic equation, and we know that quadratic equations are continuous in the interval x belongs to R, and therefore when this function is defined as minus x squared plus 4x minus 2, we know that within this open interval 1 to 3, the function is continuous, right? And again, like I mentioned in all my problems, as per the recommendation, please do pick up a number within this open interval, and you know uh, request you to apply the continuity conditions and check for continuity and prove that the functions is indeed a continuous function. So here we are skipping those steps because we know that these are basic functions, and therefore we know that they are continuous, right? But when it comes to the examination, I would recommend that you apply the rule even for these functions and showcase that these are continuous functions, right? Let's not assume that the examiner is going to treat this as a simple assumption and move on, right? So let's do that. So we have our part 3 is again continuous, and my part 4 which is x greater than 3, right? And what is my x greater than 3? X belongs into the open interval 3 to infinity, right? 3 comma infinity, right? And what is that? F of x takes a value 4 minus x, right? Again, simple linear polynomial of degree 1, and therefore we can conclude that this function is continuous, right? So we have all the four parts done now. Now we'll examine the critical points, right? Now what are those points? Function undergoes a transformation from 0 to x at 0 to x at x equals 0, and then at x equals 1 there is a transformation, and then at x equals 3 there is a transformation. So we have three critical points uh, to examine. So x equals 0, and that will be our first point, right, which is our part 5. What is my f of x equals 0, right? And for x lesser than yeah, my f of x equals x, right? So let us write that down. F of x equals x, and f of x equals 0 means x equal to 0, which is 0, right? And what is my LHL? My LHL is nothing but I approach 0 from the left, right? And when I approach 0 from the left, what is that function? It will be 0, right? So I can straight away conclude that my LHL is 0. And what is my RHL? My RHL is when I approach 0 from the right, which means I'll have to pick up x greater than 0, and therefore I'll have to pick up x, right? So what is my RHL? My RHL is limit x tending to 0 plus. And what do I have? X, right? So I don't think I will discuss this in detail. This is pretty simple and straightforward. And what is our limit? It is 0, right? So we know that at x equals 0, my f of x at x equals 0 is finite, and my LHL and RHL are equal, and they are equal to f at x equals 0, right? F is f is continuous at x equals 0. So let's move to the next critical point, which is x equals 1, which is going to be my part 6, right? 6, which is x equal to 1, right? Yeah. So I have my f of x equals 1. And what is my f of x equals 1? F of x equals 1. My f of x at x equals 1, my apologies. It is this function, right? Minus x squared plus 4x plus 2. And what is that? It is minus 1 square, which is 1, plus 4 minus 2. So what is that? Minus 1 plus 2 is plus 1, right? Now I have my LHL and RHL to be established, right? And what is my LHL? My approach 1 from the left, right? And what is that? X tending to 1 minus. And when I approach 1 from the left, what is that function it takes? It takes x, right? So let us write that down. It takes x, and this is simple, folks. I have 1 minus h, and h is infinitesimal, and therefore it takes a value 1, right? And what is my RHL? My RHL is f of x equal to 1 plus, right? And when I do that, I calculate I approach my 1 from the right, right? And therefore I will have to call on my limit symbol where I approach 1 from the right. And what is that function it takes? It takes the function this, right? Minus x square plus 4x minus 2, right? So I'm going to put that out here. And what is my limit? My limit is minus, assume x equals 1 plus h. My h will be infinitesimal, and therefore I have this as minus 1 plus h minus 1 plus h the whole square plus 4 into 1 plus h minus 2. And what is that? My h is infinitesimal, and therefore it is minus 1 plus 4 minus 2, right? And what is that? 3 minus 2, which is 1, right? So at the point 1, I have my f of x, which is 1. I have my LHL, which is also 1. And I have my RHL, which is also 1. And therefore, I can conclude that my f is continuous at x equals 1, right? So we are good so far. And we have one last point to examine, which is the point 3, right? So let's do that in a very similar fashion. That is going to be my part 7, where x equals 3, right? And what is my f of x equals 3? What is the function f of x definition when x equals 3? It is this, right? 4 minus x. So let's pull that out, which is 4 minus x, which is 4 minus 3 is equal to 1, right? And let's do our LHL, which is nothing but I approach 3 from the left. Means I call out my limit function. I call out my limit function, and I'm going to approach 3 from the left, which means it is a 3 minus. And approach x from the left, what is that function? It is going to be this function, right? Because this is the function which is applicable for all values lesser than 3, right? And when we approach it from the left, x is going to be 3 minus. So we will have to use this function to evaluate the limit, right? So let's evaluate the limit. I think this is, so when x is tending to 3 from the left, I'm going to substitute my x by 3 minus h, and 4 times 3 minus h plus minus 2, right? And what is that? Minus 9 plus 12 minus 2. And what is that? 3 minus 2 is equals 1, right? So that is my f of 3 minus. And now I have my RHL, 3 plus, right? And what is that? That is nothing but my limit extending to 3, but from the right, right? So let's write that out. Extending to 3 plus, extending to 0, where I know that my h is infinitesimal. It takes a value 3 plus x takes a value 3 plus h. And what is it when I approach 3 from the right? It's going to take this function, right? 4 minus x for x greater than or equal to 3. So which is simple and straightforward. And we have 4 minus 3 plus h, and we've got 1 minus h, which is 1, right? So we have done both these steps. We have done our f at x equals 3. We have done our LHL and RHL, and we notice that our LHL and RHL are equal in this case. So which means that the limit does exist, and they are also equal to f at x equals 3, which means the function is continuous at x equals 3 as well, right? And what are we left with? Are we left with any other points to examine? The answer is no. So here we have a function which is continuous at x belonging to R, right? And therefore we can summing up all parts. We know f is continuous at x belonging to R, right? R. So that's how we solve this problem. I hope you found the problem useful. Please do subscribe to my channel and support. Thank you.